Hello, space enthusiasts. Welcome back to our channel, where we dive deep into the mysteries of the cosmos. Today, we're tackling a colossal topic, the potential collision between our Milky Way galaxy and the neighboring Andromeda galaxy. It's a scenario that has sparked debates and curiosity across the scientific community. So, will our galaxy really collide with Andromeda? Let's explore the possibilities. For centuries, astronomers believed that a cosmic collision between our Milky Way and the neighboring Andromeda galaxy was not just possible, but inevitable. They predicted that within the next 5 billion years, these two galactic titans would merge. Recent simulations, however, have cast a shadow of doubt on this stellar certainty, suggesting the collision might be as unpredictable as a coin toss within the next 10 billion years. The general consensus might be less likely now, though it's certainly not off the table, said Manasvi Lingam, an astrobiologist at Florida Institute of Technology, who weighed in on the findings for Space.com. Andromeda, also known as Messier 31, is just 2.5 million light-years away, making it the closest large galaxy to our Milky Way. Scientists have been tracking Andromeda's trajectory towards us since 1912, noting its approach at a swift 68 miles per second, 110 kilometers per second. Earlier research had almost assured a head-on collision, envisioning the two galaxies locked in a gravitational embrace and eventually melding into one elliptical galaxy, whimsically named Andromeda. Galactic mergers, once a common sight in the cosmos between 6 billion and 10 billion years ago, have dramatically sculpted the universe we observe today. Evidence of these ancient collisions lingers in the Milky Way, hinting at a past filled with cosmic cannibalism. However, predicting the ultimate fate of our galaxy involves a level of uncertainty that even the most advanced observations can't fully resolve, as recent research led by astronomer Till Sawala at the University of Helsinki reveals. The study points out a critical oversight in earlier models. They often ignored the gravitational influences of smaller neighboring galaxies. These forces could significantly alter the trajectory between the Milky Way and Andromeda, potentially steering them away from a catastrophic merge. According to Sawala's latest findings, there's now a 50% chance that the two galaxies might not collide at all. The much talked about end of our galaxy may be more fiction than fact, the researchers suggest. Leveraging fresh data from the Gaia and Hubble Space Telescopes, Sawala's team has modeled various futures for the local group, the Galactic Family, that includes the Milky Way, Andromeda, and several smaller galaxies. Each scenario unveils different paths our galaxy could take, reminding us that the universe often holds more surprises than certainties. When researchers factored the Triangulum Galaxy 33 into their simulations, the third heaviest hitter in our local cosmic community, the likelihood of a galactic merger ticked upward. Yet, introducing the orbit of the Large Magellanic Cloud, which cuts perpendicularly across the path linking the Milky Way and Andromeda, significantly dampened the odds of a union within the next 10 billion years. If the galaxies avoid a direct collision, they will skirt past each other at a considerable distance, explained Lingam. The extent of this distance could cause turmoil in their outer reaches, potentially hurling stars and stellar debris into the void. Despite these nuances, the study maintains a 50% chance that a merger might still occur, a statistic Lingam underscores as far from trivial. Even if a collision does transpire, its immediate impact on individual planetary systems, including ours, would likely be minimal. However, there's a lot we don't yet know, he cautioned. The ongoing Gaia mission, renowned for producing the most detailed maps of the Milky Way, promises to refine our understanding further. As Gaia continues to gather data, astronomers hope to clarify which neighboring galaxies might significantly sway the potential mega-merger's fate. If the Milky Way and Andromeda galaxies do ultimately converge billions of years from now, the aftermath could transform our cosmic neighborhood dramatically. Astronomers speculate that such a collision would catapult our solar system into one of the new galaxy's outer arms. Stars flung from their usual orbits would trail dazzling cometary tails across the sky, while squeezed clusters of gas and dust would ignite new stars in brilliant bursts of creation. Despite the dramatic reshuffling, this cosmic merger is expected to unfold with surprising calm, thanks largely to the vast stretches of empty space within each galaxy. As our universe continues its relentless expansion, distant galaxies would drift even further from our view, eventually leaving Andromeda as the sole celestial city in our observable universe. By this distant future, humanity, at least as residents of Earth, would be a relic of the past. The expanding sun will have scorched our planet into uninhabitability long before the galaxy's grand finale, leaving any lingering witnesses to find shelter elsewhere in the cosmos. Galactic collisions might sound catastrophic, but they are a common occurrence in the universe. Our Milky Way is currently on a path that many scientists believe will lead to a merger with Andromeda. This event, projected to occur in about 4 billion years, is not only fascinating, but also a natural part of galactic evolution. In this segment, we'll unpack what galactic collisions are and why they're essential to understanding our universe's life cycle. The Milky Way and Andromeda are two massive spiral galaxies, each containing hundreds of billions of stars. Despite the vast distances between stars, the gravitational pull between these two galaxies is drawing them closer at a rate of about 110 kilometers per second. What does this mean for both galaxies, and what can we learn from their trajectories? Here, we'll delve into the mechanics of this slow-motion cosmic dance. Imagining two galaxies colliding can evoke images of chaos and destruction. However, the reality is quite different. Given the vast distances between stars, the likelihood of direct stellar collisions is minimal. Instead, the merger would be a gradual blend, reshaping the galaxies over millions of years. In this part, we'll explore the phases of the merger and its potential impact on the galactic structures. If and when the Milky Way and Andromeda finally meet, the resulting formation could be a new type of galaxy, often speculated to be an elliptical galaxy. This new galaxy, sometimes humorously dubbed Milkomeda, would mark a new era in our cosmic neighborhood. What are the scientific predictions for this new galaxy, and how would it affect our understanding of the universe? While the collision theory holds strong, there are alternate viewpoints and emerging studies that suggest different scenarios. Some recent simulations suggest variations in the predicted path, possibly altering the collision course. Could Andromeda miss the Milky Way entirely? In this final segment, we'll discuss the debates and the fascinating uncertainties that keep astronomers on their toes. In understanding galactic collisions, dark matter plays a crucial role. It makes up a significant portion of both galaxies' mass and influences their gravitational interactions. In this segment, we will explore how dark matter's elusive presence might affect the dynamics of the Milky Way and Andromeda as they draw closer. What happens to solar systems like ours when galaxies collide? We'll delve into the gravitational effects that could disrupt planetary orbits or potentially fling some systems into new positions within the merged galaxy. The fate of Earth and our solar system in this grand event is a topic of intense scientific interest and speculation. Galactic collisions can trigger new star formations as gas clouds in intersecting galaxies collide and condense. This segment will focus on how these events might lead to a burst of stellar birth, influencing the evolution of both galaxies. As Andromeda and the Milky Way merge, their galactic cores will eventually coalesce. This process could lead to dramatic changes, including the formation of supermassive black holes. We'll discuss the science behind galactic cores and what might happen when these massive entities meet. Looking beyond our own cosmic neighborhood, there are other ongoing galactic collisions in the universe. By studying these distant mergers, astronomers gather clues about the fate of our own galaxy. This segment covers some of these extragalactic collisions and what they tell us about our future. Each galaxy hosts a supermassive black hole at its center. What role will these black holes play when galaxies collide? We'll explore the interactions between these gigantic forces and their impact on the merger process. The Milky Way is known for its prominent spiral arms. This segment examines how these features might be altered or even dismantled during the collision, transforming our galaxy's familiar structure. Andromeda itself is quite different from the Milky Way in several ways, including its size and structure. We'll take a closer look at what makes Andromeda unique and how these characteristics could influence the collision. Gas and dust play a significant role in the structure and evolution of galaxies. In this part, we discuss how these materials could affect the merger, potentially fueling further star formation and altering the galaxy's appearance. Sometimes described as galactic cannibalism, larger galaxies often absorb smaller ones. We'll compare the Milky Way Andromeda event to other known cases of galactic cannibalism and what these events suggest about the nature of our universe. Advances in technology allow scientists to simulate galactic collisions on supercomputers. This segment will delve into how these simulations are conducted and what they have revealed about the potential outcomes of our galactic merger. What are the broader implications of galactic mergers like the one predicted for the Milky Way and Andromeda? This part explores how these events shape the large-scale structure of the universe over billions of years. As the predicted merger approaches, what can we expect in terms of advancements in observational astronomy? We'll discuss the future technologies and missions that may allow us to witness this event more directly. Merging galaxies may disrupt habitable zones. In this segment, we examine the potential impacts on the habitability of planets within the Milky Way and Andromeda, considering both risks and new opportunities for life. Galaxies are not isolated entities. They interact and influence each other through gravity. This segment will focus on the concept of galactic ecology, the study of how galaxies affect their surroundings and evolve together, setting the stage for understanding the larger context of the Milky Way-Andromeda collision. Both the Milky Way and Andromeda have several satellite galaxies. We'll explore how these smaller companions could affect or be affected by the major merger, potentially joining the larger collision or being flung away into space. Magnetic fields stretch across vast areas of galaxies and can interact dramatically during a collision. This segment discusses how these fields might influence the dynamics of the merger and the subsequent evolution of the galaxy. As galaxies merge, their spin and orientation can change significantly. We will analyze how the angular momentum of the Milky Way and Andromeda might evolve as they come together, potentially altering the rotation of the resulting galaxy. Imagine looking up at the night sky in a few billion years. What would we see as Andromeda grows larger over the horizon? This part will paint a picture of future skies and discuss how the changing view will mark the progress of the merger. Beyond just simulating two galaxies colliding, cosmological simulations take into account the entire universe's expansion and evolution. We'll dive into how these simulations help predict not just the fate of Milky Way and Andromeda, but also the future of the cosmos. The Milky Way and Andromeda are part of the Local Group, a cluster of galaxies. This segment explores how their merger might affect the dynamics of the entire group, potentially leading to further mergers or rearrangements within the cluster. As astronomers and space enthusiasts, preserving knowledge and cultural significance of our own galaxy becomes a topic of interest. We'll discuss how the concept of galactic heritage might evolve as we face the merger and what it means to maintain a legacy that spans billions of years. Dark energy is a mysterious force driving the universe's accelerated expansion. This segment will speculate on how massive galactic mergers might provide new insights or challenges to our understanding of dark energy and its influence. As the Milky Way and Andromeda galaxies merge, they will create a trail of debris, including stars and gas. This segment explores how this debris could form tidal streams and smaller satellite galaxies, reshaping the local galactic environment and potentially creating new celestial phenomena. The Cosmic Microwave Background (CMB) provides a snapshot of the early universe. We'll discuss how a galactic merger might influence our observation of the CMB by introducing new anomalies or distortions in this cosmic relic radiation, potentially providing new clues to the structure of the universe. Galactic mergers are expected to produce ripples in spacetime, known as gravitational waves. This segment delves into how the collision between Milky Way and Andromeda might be detectable by future gravitational wave observatories, opening new avenues in astrophysics research. The chaotic environment of merging galaxies could influence the formation and stability of exoplanets. We'll explore the challenges and opportunities in searching for planets in such dynamic settings, and what these studies could reveal about planetary formation and survival. How does the potential merger between our home galaxy and its neighbor capture the cultural imagination? This part discusses the influence of such cosmic events on literature, art, and philosophy, reflecting on how humanity perceives and artistically represents cosmic scale changes. Anticipating a galactic merger might spur technological advancements, particularly in space observation and simulation technologies. We'll review potential tech developments aimed at better understanding and possibly even navigating the future cosmic environment. As the galaxies merge, the changing cosmic landscape could pose new challenges for interstellar communication, especially for future space missions. This segment examines potential disruptions and the need for adaptive communication technologies in an evolving galaxy. Investing in astronomy and cosmology has far-reaching implications, including economic benefits. Here, we discuss how sustained interest in galactic events like the Milky Way-Andromeda merger could drive funding and innovation in science and technology sectors. With our understanding of the universe expanding, so too do our ambitions for space exploration. This segment looks at how the knowledge of an impending galactic merger might shape future missions, focusing on exploration beyond our solar system and potentially to other galaxies. Galactic archaeology involves studying the structure and history of galaxies to understand their formation and evolution. In this segment, we delve into how the Milky Way-Andromeda merger will serve as a live laboratory for galactic archaeologists, offering unprecedented insights into the processes that shape galaxies. The interstellar medium, the matter that exists in the space between stars, will undergo significant changes as the galaxies merge. We'll explore the impact of these changes on star formation rates, the distribution of elements, and the overall chemical richness of the resulting galaxy. As the Milky Way and Andromeda come together, their dynamics, how they move and interact, will evolve. This segment focuses on the theoretical and computational models that predict these dynamics and what they tell us about the behavior of galaxies on a grand scale. Astrophotography will capture this merger over millennia, providing a visual history of the event. We discuss the advancements in imaging technology needed to document such a prolonged and dynamic event, and the role of amateur astronomers in this epic endeavor. Neutrinos are elusive particles that rarely interact with matter. This segment examines how the merger might affect neutrino emissions from the galaxies and what these changes could reveal about the role of neutrinos in cosmic events. The knowledge that our galaxy is heading towards a monumental change can have a deep psychological impact. We'll discuss how understanding our cosmic fate influences our worldview and mental health, and the role of education and outreach in mitigating existential anxiety. Galactic mergers can alter the paths and intensities of cosmic rays. This segment looks at the potential for new research into cosmic radiation, its sources, and its effects on galaxies and potentially on Earth. Our perception of time is challenged by events that span billions of years. Here, we reflect on how the merger recalibrates our understanding of time, both scientifically and philosophically, extending our perspective far beyond the human scale. Future space missions may need to navigate a changing galactic landscape. This segment explores the implications for spacecraft trajectories, navigation technologies, and mission planning in a galaxy that's merging with another. As galaxies merge, the potential for changes in habitable zones and the conditions for life arises. This segment explores how astrobiology could benefit from studying the effects of galactic mergers on the distribution and potential for life, both microbial and complex, across merging galaxies. Galactic winds, powerful outflows of gas, driven by star formation and black hole activity, can reshape galaxies. We'll delve into how these winds might interact and transform during the merger, influencing star formation and intergalactic material distribution. By comparing the Milky Way-Andromeda merger with other known galactic collisions, astronomers can form a more comprehensive understanding of these events. This segment focuses on what we can learn from other mergers currently observable in the universe. Mapping the new structure that will result from the Milky Way and Andromeda merger will require advances in galactic cartography. Here, we discuss the future tools and techniques that will be necessary to chart the evolving cosmic geography. Besides the major structures of the Milky Way and Andromeda, numerous smaller stellar groups and clusters will also interact. This segment explores their role and the dynamics they bring to the overall merger process. How will future cultures view and represent the merger of our galaxy with Andromeda? We'll look at how this event might influence art, media, and storytelling, becoming a motif or symbol of broader human themes. As the need to observe slow, grand-scale cosmic changes grows, so too will the technology to watch them unfold. This segment reviews upcoming advancements in telescopic and observational technologies specifically geared toward watching events like the Milky Way-Andromeda merger. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.